onto the back page where we get into some more algebraic process. It says for us to rotate this figure, and this is part 2 of our rotations on a coordinate plane, by the way. Rotate the figure as shown on the right 90 degrees, then 180, then 270. After each rotation, we're going to record the coordinates of the image in the appropriate table. So, once again, when we talked about turning this, if we start here, 90 degrees is one turn here, 180 degrees is two turns, 270 is three. So what do we mean by that? How do we do that with this paper? So we're going to start with 90 degrees clockwise, and literally clockwise is one turn. So we're going to turn our paper just like this once. Okay, so now that we can see our original was A was 2, 1. So our new A is going to be 1, negative 2. So we'll go plus 1 and down 2. So A prime is 1, negative 2. Okay, let's go ahead and write the rest of these down just so we can have it. B is 1, negative 6. And then C is 7, negative 4. Once again, I turned the paper one time and I was able to go across to my x value and go down to my y value. So I can see 7, negative 4. So disregard the signs, just count the spaces and it helps you find your new spots. So now from there, in our own words, what happened from our original, which is xy, to our new? Well, it looks like x and y switched places. I'm just going to write switched. Okay, and then the y value became, or not the y value, the x value became opposite. So 2 went to the y spot. So if this is x, y, then y switched places, and then the x value turned opposite. So x becomes opposite. Okay, so in that says original becomes y, negative x, or opposite x. Okay, these words say what this is. Remember, algebraic representation is just a process. So let's go ahead and do that again for 180 degrees. Remember, 180 degrees clockwise or counterclockwise is 2 turns. So we'll go up here and turn this. So 1, that's 90 degrees. 2 is 180 degrees. So now if I were to count over here to go across, we go 1, 2. So negative 2, negative 1. So that's A, negative 2, negative 1. B is negative 6, negative. And C is negative 4, negative 7. Once again, negative 2, negative 1, negative 6, negative 4, negative 7. Let's go ahead and fill these in. So negative 2, negative 6, negative, and negative 4, negative 7. Okay, so now what happened here? X and y became opposites of themselves. I'm just going to write became opposite. The reason why I'm not writing negative is because there could be a situation where your coordinates are in a negative plane, a negative quadrant, and the opposite of negative is going to be positive. So in this case, we're going to say from our original x, y, the new one is the opposite of x, the opposite of y, or negative x, negative y. Okay? All right, next one, last one of the rotations. We have 270 degrees clockwise or 90 degrees counterclockwise. Okay, so we start at the top right here. Remember, 270 is 3 turns, so that would be 1, 2, 3. Okay, or if I start at the top, this would be the same as going 90 degrees counterclockwise, which is 1 like this. Okay, so we are going to write our coordinates here. This is going to be for A, negative 1, 2. B is negative 1, 6. And C is 7, comma, -7, comma 4. So once again, -1, comma 2, -1, comma 6, -7, comma 4. Let's write those down. Okay, so a -2, no, -1, sorry, so +2. So -1, comma 2 is going to be a -1, comma 6, and then this is going to be a -7, comma 4. Okay, so in this case, as we're looking, X and Y switch, because we're trying to see what happened from our original to our new. So X and Y switch, okay? And then in this case, if I'm looking from 2, 1, and I go -1, +2, this says that the Y turned negative while X stayed the same. So we're going to say Y becomes opposite. Okay, so X and Y switch and Y becomes opposite. So now, what does that look like algebraically? Well, once again, from our original, we have X comma Y. Okay, you'll usually see it like this. And that becomes, well, we say Y becomes opposite, so go ahead and do that now. Y becomes opposite, and X stays the same. Okay, so one thing you'll notice with your rotations is that your 90 and 270, notice Y and X switch places, whereas your 180 stays the same. Okay, there are some patterns that you can recognize, but they're for more or less, these are the 3 that you're going to look at. And then if you need to memorize them, I'd start here. But remember, you can always arrive at your algebraic rules by just simply turning your paper. Okay? So now we're going to use these rules up here, these in your own words, to figure out what happens with 8 through 10. So we have X, which says 9, comma 8, and that becomes 8, comma -9. Well, what happened? This is X, comma Y. X and Y switch places, so Y is here, and this 9 went from positive to negative, so that is a -X. So X and Y switch, X becomes negative or opposite. If X becomes opposite, that tells me right here, X and Y switch, X becomes opposite, Y comma -X, that is 90 degrees clockwise. So we're going to write 90 degrees clockwise, or 270 counter. Okay? Let's look at number 9. We have -4, comma 5 becomes -5, comma -4. So in this case, we have X, comma Y, that becomes Y switches and changes sign, so that's a -Y, and X stays the same. So X and Y switch, and Y becomes opposite. So which rule is that? Or rotation is that? That X and Y switch, Y becomes opposite, 270 clockwise. So that's 270 degrees clockwise. Okay? From there, we'll do the last one, and it says Z is -6, comma -1, and that becomes Z prime, which is 6, comma 1. The 6 and 1 are in the same spot, so XY, XY, but there is a difference. These went from negative to both positive, so they became opposite versions of themselves. So this says X and Y become opposites. And the one that says X and Y become opposites is 180 degrees clockwise. So 180 degrees clockwise. All right, so some follow-up questions. And to summarize, remember, we have our 3 different rules here. We know that rotations turn a figure about a fixed point of rotation. Your turns are in increments of 90 degrees, and you have 90, 180, and 270 degrees. Your rules are posted here, so you can refer back to them there. These are what those rules say in human language. And then lastly, to finish this up, talk about some orientation here. So the word orientation just means turning, right? So it says, do the rotations preserve or change orientation of the figure? So what they mean by that is basically, if I have this paper here, orientation of the figure says, does it flip? Does it invert like this? Okay. Well, we've seen on our paper that they do not do that. Rotations do not do that. So we're going to say no. But the last question, number 12, do they preserve or change the orientation of the figure? So we're going to go with preserve and circle that for this one. Sorry, I forgot. It preserves the orientation of the figure. But do they preserve or change the orientation of the vertices? Well, if I look here, my vertices are my corners. But what happens when I rotate this? If I were to put letters there, it would be in different locations, right? So we would say safely that rotations change the orientation of the vertices. Okay. So that sums up what we're doing with the notes for rotations on a coordinate plane. Once again, please like, comment, follow, subscribe, share. Please put if you need any extra tips for any other content in the math world, and I'll be gladly to help you out. Thanks once again. Take care.